We experience physics in our everyday lives in everything that we do. As human beings, it is our job to be aware of the physics around us in order to have a better understanding of our surroundings. During our physics field trip, we experienced Newton's three laws of motion firsthand. Newton's first law of motion states that objects will remain at rest or in uniform motion in a straight line unless acted upon by an external force. Newton's second law of motion states that if the force applied on an object is the net external force, then the force will be equal to mass times acceleration, though this does not apply in any cases where the mass is changing. Newton's third law of motion states that every action has an equal and opposite reaction. In order for an object to achieve a net force and an acceleration, it must interact with an object external to itself. Now let's discuss how these three laws is related to the destinations of our trip. The myth of the human body exhibit had a lot of cadavers that were at rest. In order for an object to be at rest, all forces acting upon the object must equal zero. This does not necessarily mean that no forces are acting upon the cadavers. In some cases, the body parts of the cadavers in the exhibit were supported by stands which negated the force of gravity. Some of the frail body parts relied on the tension of strings to keep them from falling or snapping off. This information relates to the first law of motion because the cadavers are at rest because of the external forces canceling each other out. As for the second law of motion, considering that the cadavers are at rest, they have an acceleration of zero. If you apply it to the formula, no matter what the masses of the cadavers and their body parts, the force will always be zero as long as they are at rest. For the third law of motion, the action is the force of gravity being applied to the cadavers along with the tension of the strings and the support of the stands. The reaction to this is the state of equilibrium between those forces, which results in the state of being at rest. In Ocean Park, we experience a variety of aquatic animals as well as flightless birds and their movement underwater. These animals use their fins and flippers in order to move swiftly across the water. We also experienced the sea lion show. The mammals slid across the concrete using their incredibly smooth skin and the water that coated them from occasional dips inside the pool. We can relate our experiences at the ocean park to the first law of motion as inertia plays a big role in the movement underwater. The fish have to constantly use their fins to remain in motion underwater because of the water resistance. Water resistance makes it harder to move around underwater, which ultimately decelerates objects in motion underwater. In the case of the sea lions on land, they use their smooth skin and water-coated bodies to decrease the force of friction that is normally acted upon them when sliding on concrete. For the second law of motion, both the fish and the sea lions have an acceleration underwater when they are moving, though their acceleration is not constant. As their acceleration slows down, the less force that the body would have to exert. In layman's terms, the less work their body puts into swimming, the slower they will go. For the third law of motion, every time they exert force using their flippers or fins, be it underwater or land, the reaction would be their velocity. A good example of this is when the sea lions push their bodies in order to start sliding on land. At Enchanted Kingdom, we rode a variety of rides that gave us a lot of different examples of how physics relates to the functions of the rides. Most of the rides at Enchanted Kingdom was created to accelerate to a maximum speed and maintain that constant speed until it was time to slowly decelerate using a smooth brake system. In the air race ride, they used centripetal force in order to keep the passengers from falling when the planes went upside down when rotating vertically. For safety measures, they installed safety vests to secure the passengers in their planes. This ride uses gravitational force in order to move the spinning platform across a massive half-pipe. If it wasn't for the smooth brake system, the spinning platform would have flown off the tracks eventually due to the combined mass of the passengers and the huge metal platform. How far the spinning platform goes across the half-pipe depends on its force. The spinning platform also contains centripetal force. If the seats were not secured properly, the passengers would have been launched at some point during the ride. Thank you guys for watching.